Okay, well, we are at the magic 10 after the hour, so I'm going to get us started promptly. I think there are still a few muffins in the back, so feel free to get up and grab one during the talk if you'd like. I am happy to be here today, and I'm happy that the various people involved in the project are all going to get a chance to talk. So we're going to kind of tag team our way through this one. Andy Krumm is a PhD student in the School of Ed, who's, well, I put Andy this close to finishing. Joe Waddington is also a PhD student in the Ed School, who I think is that close to finishing. Okay. Steve Lonn, many of you know, he is a staff member in the use lab because he finished his PhD from the School of Ed. And I'm Stephanie Teasley. I'm a research faculty at the School of Information and the director of the use lab. This is a project that we have been working on with the MSTEM Academy, which I think Andy's going to tell you more about. So I'm going to let him do that. Thank you. Forgot which slide.
So as Stephanie said, I'm Andy Krumm. I'm just going to do a brief introduction of our talk, and you'll see more of me later. What we're going to talk about today is the history of the project, how it got started here at the University of Michigan. Our partners, as Stephanie mentioned, the MSTEM Academy. We're also going to address the overall purpose for the project in terms of its implications for the broader idea of learning analytics in higher education. We're going to discuss specifically how we're supporting MSTEM mentors working with undergraduate engineering students and the main source of data that we're drawing on, which is from C-Tools. And so we're going to walk you through how we grab the data, how we analyze the data, and how we then present it to mentors to support their mentoring activities. We're also going to introduce something we're calling classification schemes. It's a little different than some of the presentations we've heard so far who are addressing ideas of prediction models. We're going to go a little bit away from the idea of prediction and try and come up with different displays that help mentors classify students and how that can help them in their mentoring activities. And then we'll talk about some of the feedback we've received from MSTEM mentors, as well as some different displays and how we're starting to prod the issue of evaluation and whether or not what we're doing is helping the MSTEM Academy as well as undergraduate engineering students. And then we'll address some next steps and where we see this project going. So I'm going to turn it over right now to Steve, who's going to tell you a little bit more about our collaborators, the history of the project, and the MSTEM Academy.
So our project is what we call very uniquely University of Michigan, where it's had some fortuitous meetings with each other. So the Use Lab began investigating C-Tools and learning management systems in generally back in 2004 by looking at use and perceptions by faculty and students. Part of that was because we were part of the lab that helped originate Sakai and the C-Tools instantiation here in Michigan. So our annual survey, partially based on some earlier LMS work in EDUCAUSE and other places, has become an important series of metrics used around campus. Along with that work, we began to extract log data from the C-Tools as a way to compare the perceptions with actual use between perceptions in the survey and actual use. So actually grabbing when people go in, what do they download, what announcements are actually posted, how often do they log in, those kind of things. And we've written several conference and journal articles that describe the differences between instructors and students, residential and commuter campuses, between broadcast interactive uses of LMS features. At one of those conference presentations in 2010, we began to receive comments on our work that, while very informative, didn't provide necessarily a direct link between LMS use and student learning outcomes. So one of our questions is, what outcomes do we focus on first? Do we look at final grades, final course grades that are available to us? Do we look at information from the online grade books? Or is there other information we should be pulling from? How do we integrate actually how people are using the LMS? Where do we focus? In October that year, Sean DeMonner from ITS, that many of you know, had heard about a tracking and retention program in the College of Engineering. That was during one of those academic technology planning committees. He suggested I contact James Holloway over in engineering, and he was pretty skeptical whether LMS activity, at least by itself, would be very informative. But he said, well, why don't you have a talk, contact these folks over at MSTEM Academy, and they might be able to help you. And the next question was, what's MSTEM Academy? Because we had never heard of it. So MSTEM Academy is a program that they're now in their 4th year, and they focus on the first 2 years of coursework in engineering as an effort to increase retention and student success of those who might not be as successful as their peers. What they do is they invite they take the admitted students every year into the College of Engineering, and they invite roughly 200 of them based on about 20 different criteria, including ACT scores, first-generation student status, high school ranks, ethnicity, gender, etc. And they try to enroll about 50 students every year in the academy. And what do? They get a $3,000 stipend as a financial incentive during their first year to complete all the required mentoring and peer activities. That includes summer intensive courses, workshops, custom advising, career guidance, academic learning, enrichment activities, and a whole lot. And they had some really good initial success in the first couple of years of their program. But what happened is they were relying on student-supplied information about how they're doing the core courses. So often this information would be incomplete, or the student might forget to fill out the sheet before the meeting, or I forgot it at home. Furthermore, if the advising session was scheduled too close to a student's exam, it would often be too late to intervene, and too late to really change the student's behavior before they turned out not to perform as well at the exam as they might otherwise have. So we needed some way to get up-to-date, they needed a way to get more up-to-date student performance and effort information to the academic mentors as quickly and efficiently as possible in order to make kind of affect change. Hence the purpose of our project. So we've been exploring this problem space in late fall 2010 as explained, and began understanding the different elements and constraints that were available to us in winter 2011. So by the end of winter 2011 is when we delivered our first version of this kind of data to the mentors. By summer, we were ready to start deploying a weekly report the mentors could use in the normal work routine. So really we want to identify practical ways that we could use the MSTEM Academy really as a test bed to eventually scale this work more broadly throughout the College of Engineering and potentially also throughout greater University of Michigan. So working with the MSTEM mentors, our work process was really to quickly and iteratively develop a way for our team to deliver relevant data from C-tools in a way that made sense for mentors to distinguish which of the roughly 65 students, because if you take, they have about 200 students total in the program now, so about 65 per the 3 mentors, to which they're assigned in the MSTEM Academy, which one of those needed most help and which course in any given week. So our team developed a variety of different classification schemes and visualizations based on our own work with the LMS, as well as some of the initial forays into learning analytics that were discussed earlier in the SLAM series. So our first version of this work was to assemble a large Excel file that mentors were able to download on a weekly basis. So right now, we're working with the mentors. Much of our interaction is focused on the design of the data presentation. How can we present data that is actionable and easy to understand from the mentor's perspective? Some of the infrastructure we're using is the C-Tools Event Archive, the actual grades and assignment data available within the C-Tools database. And with the help of some of the gentlemen in the back there, we are hoping to eventually move towards the using the Data Warehouse, the Business Objects Reporting System, and also integrate some demographics and academic history as well. So part of the SLAM series is we actually want to show you actual data. So Joe's going to start digging into the data for you.
So thanks, Steve. I'm going to talk a little bit about the process that we go through really on a weekly basis, going from the raw C-Tools data to the final product that we send to mentors. So each week we take a query of C-Tools and we only select courses where A, there's an MSTEM student taking the course, and B, where there's an active gradebook or assignments within the course. So this raw data query, as we'll show you here, is inherently messy. Here's a display of the data we receive each week from the C-Tool system. Now the gradebook is our primary source of performance information. It's a listing of all the individual assignment and test entries that an instructor enters into C-Tools. But we also grab data from the assignments, which is a supplement to the gradebook tool and does contain some additional information about assignments that are not included in the gradebook, and presents as well. I'll talk a little bit more about presents. This is our use of the course site for each student. I'll discuss that more in a moment. Okay. So the information in the gradebook and the assignments allows us to provide an up-to-date display of student information weekly to the mentors. So in our weekly reports, we provide student-level information on all M-STEM students, again, in all the courses where there's an active gradebook or assignments tool. And this includes an up-to-date measure of their performance, which we calculate as a percent of the total points that they've earned over the total points that are possible on the assignments available in the gradebook. Now, we recognize that this info we provide is only as good as exists in C-Tools. It's mostly representative of course grades when all activities are logged, such as all exams, all quizzes, assignments, labs. But it's more broadly useful to provide information to the mentors if there's more information than just homeworks or just a handful of quizzes or attendance grades. So it's really crucial that instructors enter all information about the student's grade so we can provide the most accurate measure. We also display an individual's or the course average for a course that a student is in. We find that the percentage of available points earned is doing a good job as far as how we calculate it to classify student performance. And there's lots of data from the engineering courses, especially in individuals' first and second years, as well as other STEM courses such as chemistry courses and those in physics. Math is a course that's especially important for engineering students. However, they use their own system for tracking assignments and grading of exams. We're working to integrate that data a little bit more cleanly.
So you provide course averages, but do you give people distributions or just averages?
We just provide averages for the students. We also have the course overall average. I'm going to talk about how we combine that together with the student average in our classification scheme. So it kind of keeps their grade relative to their peers based on those total points. We also wanted to consider information that was available in C-Tools beyond just grades. In essence, getting at some measure of effort that individuals are putting into the course. So each time a student logs into a course site on C-Tools, that's an event that's recorded in the C-Tools event archive. So these logins for us actually serve as a proxy for effort, and are events common to all courses. While there's other rich measures that are logged in the archive, such as resources or specific content downloads, use of forms, we needed something that all courses, there was an event that all courses were using. And we also found that the other tools that I just mentioned weren't necessarily predictive of student performance, though we're planning to go back and take a look at that as well. So I briefly want to take you behind our decision to use these logins. There we go. To use these logins as a measure. So using a technique, this is called functional data analysis, it allows us to make a display across weeks of the total number of logins or presence events, as we call them, that a student makes into a course website over the period of time. So this is a random sample of 20 students within a large first-year engineering course, Engineering 100, and we just chose a random sample of 20 students for ease of display, so you can get a representative example. The dark line, the dark black line through the middle represents the mean of all students in the course, and we've also got indicators there for the 25th and 75th percentile of students as well. So in general, those that have higher presence over the course of the semester, a higher cumulative presence over the course of the semester, tend to have higher grades, represented by the blues, greens, and some of the yellows, whereas individuals with oranges and the deeper yellows tend to appear near the bottom of the presence distribution. Now you'll notice a couple of exceptions up there. One exception are the A students. A couple of individuals that are the A's kind of fall in the, that end up with an A as their final grade, fall in the middle distribution of the presence. We hypothesize that for A students, they may not need to put in as much effort as their peers to be successful in the course. And you also notice those students at the bottom of the distribution, the dark red line and the dark orange line, individuals who have received a D or less in the course or a C minus. These may be individuals who, regardless of the amount of effort that they put in, they're still not able to be successful in the course. So as a general sort of trend, these cumulative presence events have some positive relationship with the student's final course grade and performance. Okay? We also wanted to consider an individual's logins on a week-to-week basis as well. This is a plot of the first derivative of the previous plot. In layman's terms, it basically shows the week-to-week presence, how the slope of the cumulative presence is changing over time. I want you to pay careful attention, especially to the dark orange and the red lines, those individuals who earned a C minus and a D or less in the course, respectively. It appears that at the beginning of the course, they're putting in a sizable amount of effort, logging into the course site, engaging with the course tools compared to their peers. They're doing a good job. But over time, their week-to-week presence falls off. This is what we consider something like gaming of the system, in that an individual could log in lots and lots at the start of the semester. They would turn out well on the cumulative presence shown prior. However, on a week-to-week basis, we want to take into account those downward trends that may exist as well. So we want to take into account week-to-week variation, especially for those individuals who may start out putting in a lot of effort, but later on do not. You can note a couple of peaks on this graph. You see a peak around week 7. It's of course around midterm or first exam time that individuals are logging in. Another peak around week 12, perhaps a second exam, and then a final peak near the end of the semester prior to final exams. Again, as a general trend, we see the blues, greens, light yellows, those individuals earning somewhere between an A and a B. At the top of the distribution, and the deeper yellows, oranges, reds near the bottom of the distribution. Okay? We looked at another couple of courses besides just Engineering 100 as well, and found the same general trends. There's some positive relationship between this week-to-week and cumulative presence, these logins to the C-Tools website, and final course performance. Okay. So once we compile this information on a week-to-week basis, go ahead.
I'm not very fast. Can we just stare at that for a moment and get rid of the...
Sure.
There's a lot there. I don't, it looks like the B students don't do squat. Is that my eye or?
Those are the lighter colors.
Yeah.
Some of them do and some of them don't.
Interesting.
So again, this is not all B students. This is a random sample, and this is a B student in the course. This is trying to show the general trend that the A minus, B plus, A type students tend to be higher up on their week-to-week use than.
It would be nice to see a plot like this done with all the B students in the class average.
Right.
Sure, yeah. Mm-hmm.
We're just trying not to have your brain explode when they crap up.
Well, it wouldn't have been any different, really.
If your brain explodes, no different.
Typical day.
But the averages would be well determined.
And there's another recent publication that also documents this link between use of these systems and grade up.
Well, it's clearly a link. It's just
But yeah, what's the
really
link?
interesting.
Yeah, and for who?
Because-
Doesn't matter more.
There's enough data there to actually get a fairly smooth plot for individuals.
Yeah, using the functional data analysis techniques, it sort of creates an estimate within a week-to-week time frame, trying to make like 20 little nodes to get a smoothed out plot like that.
How many data points are actually present for that 20 weeks?
Uh,
The mean for the class.
the weekly.
No, how many
Just-
visits are there to C-Tool site typically for a,
You mean number
yeah, number, total?
of logins?
Yeah.
Varies. Varies by course. So here, for example, in this course, we see the top students are around 250, 300 logins. Yeah, we had an example in this one course when we were looking at it that there was one individual who logged in 6,000 times over the period of the course, and then there's some
But
individuals.
for the
it's
typical
10.
one, it's a couple hundred, so week by week it's 10 or less.
Right.
So it's kind of noisy.
Yeah, it is. It is certainly very noisy. Yeah.
Well, and also it matters what's on the course site, right?
Sure.
So if it's just the syllabus and a couple of readings, you're going to
They
have a
never
very,
log in.
right, and that's why we do our analyses within course.
Yeah. Absolutely.
Right. If someone's got a chat window and uses it a lot, you're going to have a lot more presence events on that course if somebody doesn't.
Okay. Great. So once we compile this information on a weekly basis, we need to figure out how to display it, and more importantly, how to highlight to mentors those students who are in need of support on a week-to-week basis. So we created a classification scheme by taking into account a combination of grades as well as effort. So all comparisons, as Stephanie highlighted, are within a given class. The number of logins, the magnitude varies wildly differently across courses. So in order to come up with some composite measure that we could use for all courses, we compare individuals based on their percent rank in the class as far as their total logins. So it's always in comparison to their peers. And then the course average is another comparison method as well. So our scheme uses a couple of simple rules. Student grade is counted first and foremost. Is the first threshold for classifying students. When we talk to the MSTEM mentors and we set up these kind of thresholds at the beginning phase, one of the things that they look for and hope to help students with is to obtain somewhere around a 3.0 or higher average at the end of their academic career so that they're able to compete on the job market or in the graduate school market afterwards as well. So we kind of took that middle of the B cut point. If an individual's earned 85% or more of points, they're classified as being good to go. If you've earned over 85% of the total points, we consider those individuals as not having an issue. Likewise, on the other end, all individuals who have earned less than 55% of total available points, we don't even consider anything else. We classify those individuals as somebody who is in need of assistance. In between the 55 and 85 points of course percentage, we then start to consider things like their difference from the course average. So how are those individuals performing relative to their peers, which may push them into one category or the other. And then we also take into account afterwards their presence for those individuals that are on the margin. We'll talk briefly about the actual classification scheme as it's displayed here. So as I stated before, all individuals who are earning more than an 85 get classified as good to go. Those individuals earning less than a 55% of total points, we try to highlight to mentors that they are in need of assistance. In between, as I said, the next thing we take into account is their relative distance from the mean. So individuals, the second line up here, that are earning between a 75 and 85, but are scoring less than a difference of negative 15 points, or are further than 15 points away from the course average, we classify these individuals as yellow. Now you can see our scheme on the right here that is displayed to mentors both has colors, very similar to the Signals project, just quick visual identifier. Red, students are those are individuals who need some sort of assistance right away. Yellow individuals, you may want to follow up with that student to find out what's going on. And we've also attached names to these as well. Encourage, individuals doing well, continue to encourage them to do well. Explore, might be worth checking out. Engage, in need of immediate assistance. You can see around the margins, especially around this kind of C range margin, around the margin of Bs, if an individual is very close to the course average, We then take into account, well, what type of effort are they putting in to try to maybe push them towards one side of the margin or the other. Their presence percentile rank, we take into account both their week-to-week presence as well as their cumulative presence. Take an average of their percentile ranks. If their average percentile rank, they fall in the bottom quartile, then we shift an individual down towards being somebody that's more in immediate need of assistance. If their presence looks fine, we classify them as being okay. I'm going to turn it over to Andy now. He's going to talk a little bit more about displays and also our first implementation of the mentors using the system.
While I get this on, are there any intermediary questions right now in terms of some of the classification schemes, data, or anything like that that we've covered? Yeah, Perry.
Practical question. I'm on C-Tools. How could I find out how many students are in fact using my site? Is that something I can see?
Yeah, you should be able to see your entire roster under like the site info tab, if I'm not mistaken. Yeah.
He wants to know the usage data.
He wants to know the usage data.
Oh, he wants the usage data. Well, then that's going to require a separate query to Steve or someone in ITS to pull that. It's not normally available. There are various tools that's both in the Sakai universe and then outside of which that try and hit that data, but they're not really scalable given the amount of students we have here. So right now we just go straight to the servers, work with text files and Excel files to create these types of displays.
But is it really impractical to provide a daily report to every C-Tool site of usage? It seems perfectly practical to me.
Anyone in the back there? Anyone?
It worked.
That's one of the things I showed in my presentation is the, get hundreds of thousands of events every day on C-Tools. Eventually we'll get to the point where we might be able to do that.
Just in a kind of summary way, like, here's every student, how many times they hit today?
Yeah. For various technical reasons right now, it won't scale. We are in the process of replacing all the C-Tools underlying infrastructure. That's going to be rolled out last day of June, first day of July. So there is an outage plan. We will, after that, when we have the new hardware, those type of possibilities it's more possible as we have this kind of stronger engine build. But right now, querying, we keep all the event data in the running system for the 24 hours preceding. So getting yesterday's events would actually hit the production system of data for users to try to fill those queries. We pull off into the data warehouse from the day before. So that's why even some of the statistics that I've been generating for the whole faculty members, it's up until like the day before yesterday. But we can do, so I have the ability to do on a very limited basis some weekly stats for people, but it's informal. Okay.
So up on the screen now is the actual product that we send out to mentors. This is it's called the Mentor Summary Sheet, and this is pulled out of Excel. It's kind of a fancy screen capture, but essentially this is an Excel sheet with a bunch of different columns. The column that's hidden right now are the students, the individual student names, and those provide hyperlinks that let mentors go to an individual student report, which I'll show you in a second. But the Mentor Summary provides a lot of useful information, and in fact is one of the more useful, just in general, types of products we provide, in that you have a full list of all the MSTEM students, the courses that they're taking, how they're classified in terms of MSTEM 1, MSTEM 2, MSTEM 3, MSTEM 4, the cohort years, who their advisor is, and then whether or not and then the individual weeks for which we have gradebook information. And so because it's in Excel, we have the functionality to be able to sort and filter all these things. So an individual mentor can go in there and just identify his or her students and just limit the summary to just those students right away. The classification schemes that Joe was mentioning are then inputted on top of these individual percents that are reported. So here in the middle, there's a Chem 130 student who starts off at 60%, and while 60% may be something cause for concern, what we do is then run it through that classification scheme, a bunch of if-then functions, and go, yes, we'll mark that red. That 60% actually is something to think about because it might be so far below the mean. They might be not having as many login events as their peers. And then the mentor is able to essentially look at all of the entire universe of students longitudinally. And then in the right, in the gray, is when we provide like the most recent week. So this came from just slightly after Thanksgiving. There's an arrow that's there to provide the mentor with, all right, has this actually changed? Has the student gone up or down in terms of their performance? And then we update this course average every week as well, just so they have a nice reference there. So most of the work is done on this filtering, identifying the students that he or she cares about, and then quickly going over to the right-hand side, looking at the most recent information, how that student's classified, whether they've changed, and the course average. And there's no green because it's overwhelming. It's really a gross visual to have all that green up there. So
White is green.
yes, yeah.
And so is most of the grade? The arrow, is that just week to week? That's last week to this? Or?
Yeah, last week.
Arrow only shows up if there's greater than a percent.
And so currently we're tracking 648 unique student course combinations. So as we said in the very beginning, the way we grab data is just to identify whether or not a course site has an MSTEM student, grab all of that gradebook data. And so given that limitation and the sample we're working with, the number we end up coming up with from both engineering courses all the way to LS&A elective courses is 648.
Again, my slowness, but when you get to 103%, what does this represent? 103% of what? Of all the logins you expect? Or?
Down on the lower left, there's one, but
Oh, yeah. So
the numbers.
yeah. So these are the percents of the total points earned divided by total points possible.
Total points earned.
So that's gradebook points.
These are the gradebook points. Now
You
we
don't see the usage here, you just see it because it affects the colors.
yeah, you'll see the usage come in through the colors. And we hesitate to call them grades or grade equivalents because we're not sure how each individual assignment's weighted. There is a weighting feature within the C-Tools gradebook, but then there could also be an inherent weighting scheme that the instructor applies afterward, downloading it, putting it into his or own Excel sheet, and doing something to get a different result as well. So that's why we kind of have different percentages, like 32s and 103s, is that it's the only information that we have are the assignments that are loaded into the gradebook tool. And whether or not that actually represents the grade is something that we actually study now, trying to figure out the correlations between the data we have and whether or not the registrar's final grade for that student actually are correlated highly. Yeah.
Do you ever consider how the points are distributed across the weeks? I mean, is that something that you pay attention to?
It is on an individual course basis. And we'll get into how the mentors actually deal with that here in a second on the student display. The issue with some of these things is that we're dealing with a large number of courses. And so we have a scaling issue in terms of understanding what individual events might mean, individual assignments across those courses, and then how that translates into these percentages and usage and so forth. So here this is an example of an individual student report sheet. So on the mentor summary, like I said, the names would have been there and you'd been able to click on it, and then it would have taken you to this. So these are, in our initial design, if a student is classified as yellow or red, we're hoping that the mentor is clicking on this and digging into that individual student right away. And the top left is a longitudinal comparison of the course average, and then that student's points earned divided by points possible over time. Down here is the presence events. So we have just a simple y-axis with the percentile, and then blue and red is whether or not it's the cumulative or the weekly percentile rank in that course for the number of logins that he or she has. And then in the top right is the course that he or she's in, student meaning, what that actual effort grade is currently, 94 for this student, what the course average is, the action again is provided. And then a newer feature for this semester is to go back into the gradebook data, go back into the assignments data, and pull individual names for each one of these gradable objects, which we're finding is helping provide a lot of context for the mentors as they look across sometimes many, many courses. Yes?
So the classification rule is the same for all classes, so the course average is not in the function?
Yeah, so the classification scheme is the same across all courses, so the course average is included in each one of these for all of these courses. Are there any more questions on this or the mentor summary?
So can I
Yeah, please.
the previous slide, like if the class, like some course average is really low, like 28 is that, and so this information is also accounted into the classification.
Yes, yeah. Yeah, so the data, if you remember the one slide where it's just really gross text files with a bunch of lines and a few random code, the classifications sit on top of that, and this is just more of a polished display of all that basic information. So some of the feedback that we've gotten so far, we have 2 full semesters of actually providing this out to mentors and seeing in how they're using it and how it's affecting their mentoring with students, how students may be proceeding, and I'll get to those displays here in a second. But in winter 2011, we're basically interested in the infrastructure. We have C-Tools data, we have gradebook data. Can we get it? Can we clean it? Can we combine it? Can we display it? And so a lot of our work was geared toward, can we design something and produce a product? And so we went through an iterative design phase where we just cobbled something together, showed it to the mentors, thumbs up, thumbs down, did we like it, go back, redo, and that was what the winter term was about. And even though we were mainly focused on these infrastructure issues, they still were using it and were reporting back that the classification scheme was helpful, but because we see some of these students on a monthly basis anyway, you're not really adding all that much to us. However, for these MSTEM students who are second years, third years, and fourth years who aren't required to come to these monthly meetings, it's actually being really helpful in identifying some of these students we sort of lose after their first year of requirements of coming to these meetings are. Feature request, a big feature request, is this list of individual assignments. Because we just reported a generic percentage, both the mentors, the students, our classification schemes are hindered on what those underlying points might actually mean. So instead of trying to attenuate that within the classification scheme itself, we still just work with the brute numbers, but report to the mentors, the people who are doing the sense making around this data, the actual names of assignments. Is it a test? Is this a weekly homework? Is this a throwaway assignment? Is this a discussion posting? And that allows them to go, okay, this is something to take seriously, or maybe this red is an indication of there just haven't been a lot of points offered yet in this course. And so this ability to provide individual assignments was a very an important request that they had. And just in general, because it's in Excel, how many work with Excel? This is really clunky. And so that was a big complaint, as well as a nice source of feedback in terms of what we could do in the fall 11, which is where we were producing weekly reports. And as expected, they were using it on a weekly basis. So this was actually kind of a nice finding. We produce something for somebody, that doesn't necessarily mean that they're going to use it. But after interviewing and discussing the mentors, we're finding that, in fact, they were using this on a weekly basis. And the classification scheme is becoming more helpful. And in terms of how they're contacting students, they're immediately sending emails, contact requests to students classified as read. Some mentors found it helpful in preparing for monthly meetings. So they would download all of it and be able to examine longitudinally how students were doing. And this was a way to discuss, actually have some content to discuss in these meetings, especially for the first year MSTEM students. And then the individual assignments, they requested it, and we found that, yeah, it really did help in providing context for them and understanding what the classification scheme was spitting out and what these generic percentages that we were reporting. We made a prettier product, but it's still Excel and clunky. So we're working on moving up to the next generation of infrastructure to support these displays for mentors. The overall benefits of use then, just contacting students. You have this information. It's a really sort of easy thing to talk about. Now you have a reason to email a student saying, hey, you're getting 30% here. How are you doing? Is there a reason for this? Now it's shortening the time span between when this person identifies a student and when he or she intervenes with the student. Because we're producing on a weekly basis, it's shortening that for them. They're able to see longitudinal trends, which in some courses, some of the mentors are very well versed in what the course is, what the content is, who the instructors are. So being able to see longitudinally how a student's doing is very helpful to them in terms of whether or not this is just go see the professor or it's time for you to go see a tutoring service, for example. And then it's also helpful because we provide that big mentoring display. They can see how individual students are doing across all of their courses. So is this a big problem or is this a course-specific problem? And then just generally contextualizing MSTEM student performance. While the monthly reports were helpful in understanding the student, what we're providing is information on the student as well as the rest of that, as well as the rest of the course through averages and then how the average shifts over time.
So this is kind of like the signals thing at Purdue, except you don't send them a traffic light every week. Is there do you email the students or does it always go through the mentor?
Right now it's just going through the mentor. And that's something that we feel pretty strongly about in terms of this early phase, which is we'll provide the information. We're not trying to predict success. This is why we don't necessarily care about the inferential statistics in terms of the correlation between presence and final grade. We're not trying to write a better model. We're just trying to put really useful information into people's hands who can actually help students. And in this case, we're working with mentors who can see a broad scope of students across a broad scope of courses. So we're going to dip a little bit into how we're going to talk about evaluating MSTEM and sort of prods for how we're moving forward with the project in terms of longitudinal classification. So this is a display. Each column is a week. It's ordered by the final week in terms of their final percent of points earned. Gray is student was classified as encourage or green. Yellow is when that student was classified in that explore condition. And then red is when that student was classified in the engage condition. And I'll walk you up to the ledge. You don't have to jump with me, but I'll take you there. When you see reds and the percentage is over 70, we're going to call those sort of right now, again, you don't have to go with me, but sort of success cases. And what this type of display provides is the ability for us to go, all right, there was a student classified here as red, and then all of a sudden they're getting an 85%. Let's look at that student. Let's see his or her use data. Let's see that course. Let's see what was going on. Let's contact the mentor to see whether or not he or she intervened with that student, the manner in which he or she intervened with that student, and whether or not the student actually followed through with what the mentor suggested. So it's meant to sort of, one, dazzle you that we can make pretty charts, but then also show you these are the types of things that we're using to go, all right, if we're going to talk about whether or not having this information is helping students, we need to be able to look at all students. When do we classify them? How are they doing? And to be able to track each individual case, even though we're dealing with some 648 cases at times.
I'm seriously wow, but there's also some cases that are sort of false positives up there. I see that they're gray until the last week, and then suddenly they got 60.
Yes, so what's also interesting about this display, and you saw the classification scheme, what we can do is start to tweak some of those parameters in there and see how this diagram shifts over time. So are we getting more false positives if we weight the course average, for example, 15 to 10? 7, does presence even matter? We think it does, it's cool, we show you pretty plots. And so we can actually start to test some of these different things within our classification schemes.
These could also very well be examples where the information we have on the courses may be homeworks or quizzes, and then they get to the final exam and bomb the final exam and end up with a poor grade in the course. So.
Yeah.
Why? Yeah.
But because we have information on each individual student, we can ask these questions now. So we can put them in context with their peers across courses and within their different majors and departments and figure out, okay, what might have happened in this particular case. And we can do it for individual courses too, and this has been helpful. And this is actually an easier thing to sort of interpret as well. You can see this general trend of, okay, there's a couple students who were identified early, and then they ended up not doing so poorly. And we know from this round of interviews that mentors almost automatically emailed all red students. So you can kind of think there was something that happened there, and here you're getting to see maybe the effects of that in terms of their final grade. Again, you walk with me, you don't have to jump. This is just that general sort of way that we're starting to think about evaluating our overall success. Yeah?
What do mentors do with yellow students?
It depends on the course, and it depends on the student, and it depends on that student within the other courses. So if it's a really important course, like Engineering 101, Chem 125, you might be seeing more emails going to that student, especially if that student has had perhaps a history of not doing well up to this point. So the yellows, it's not as automatic as we know with the reds, which automatically get an email. The yellows, there's some decision making going on in terms of the mentor's thinking on how to contact that student. So our next steps is to move this into a new infrastructure. We want a web-based interface. We're people in the back with business objects and just all of the nuts and bolts that need to go into that to move us from Excel sheets into something that is much more malleable, much more pliable, and just has a cleaner interface and design. Newer versions, so this is just for mentors. We're working on displays for instructors and students. And then a messaging system. So we like what Signals has been able to do in terms of you can classify a student and send a message. Well, we're going to take our classification scheme and be able to provide a bunch of different options on how people are contacted based on this information. So this goes to that issue of scale. And so we've been banging around on some different displays, and this is one of our interfaces so far, where you, right now we have 6 options, like a high grade, low effort, a high grade, high effort. You click on that, and you'll be able to send a specific message to those students who are classified that within our data. We have fun with the words that go in there, so like awesome job, this is cool. Just playing around, while I'm guessing that will be motivating for some students, we are going to actually try and test to figure out like the actual content and what types of things are more motivating for students and what isn't. But this is also where we can start to push some of that information out to students. We can have it customized by the mentor, by the instructor, and how the messages that they want to send. And something that we found that's really useful is the ability to group it to all courses that a student's in, so you get one display from us on how that student's doing, or you can break it down course by course. So this is a really useful tool for academic advisors, mentors who need to reach a large audience of students. And right now this just sits on top of the Excel data that we're pumping out. Yeah?
It's interesting, some of the feedback that you're providing I could imagine providing similar sort of analysis and graphics to just see, who are we contacting, somehow overlaying that to look. And, you guessed that in the previous slide or two slides back. It said, probably these guys were contacted, probably that has effectively changing them from red to yellow.
Yeah, so that's Yeah, so in our next iteration, as we start to figure out how to like evaluate this and actually develop more sort of robust efficacy trials for these types of things, figuring out what the actual message was that went to a student, how that student was classified and what point in the semester. If we go to a system like this, all of that's there. And so you actually get not just a treatment, not treatment condition, you get a treatment to what degree, what was the message, what was said. And so we get a much more sophisticated understanding of what's actually happening when a student receives these types of things, because we know it. It's all stored in these server logs.
So have you
Yeah.
looked at the historical, taken the cool sort of big, tall chart and looked at that for a term before you started doing this? Because obviously you can see students who started out there and went to grade. Just on chance.
Yeah, just on chance. Yes. Yeah, and so that's, as we go forward, it's that, so we have really positive cases where we know the intervention, but again, there's just an equal probability that a student would have progressed from red to gray in any other sort of setting where there was no intervention. So we need to develop these types of displays, but then also find ways to quantify them. Because right now, they're really nice graphs and pictures to look at, but the idea of wanting to quantify it is we can figure out what's the probability of this observation, whether it was due to chance or not. So as we try and figure out ways of going, yes, red here, but ended up with a 90. Was there an MSTEM course, non-MSTEM course, are things that we're starting and have access to because all of this data is stored in the C-Tools servers. So.
Well, I think some of the next steps have been clearly hinted at here. Right now, what we're doing, I think, is just this seeing proof of concept, right? Seeing if we can do that. We love working with the MSTEM people for lots of reasons, but not the least of which it's already a successful program. It's constrained. The resources are available. They've picked the students. They're really concrete reasons they're in the program. The students are sort of contractually obligated to work with the mentors, and the mentors are paid specifically to help these students. So that is a nice place to start. So then we think about scaling it up, and then we can start to run some of these kinds of experiments that we're talking about, where we can tease apart some of these variables too, to try to see what makes a difference and how much infrastructure you need to make something like this work, what's associated with the different aspects of this. So we're starting with just proof of concept. We'll move into this more quasi-experimental design to validate some of the things that we think are going on, making sure that some of what's going on isn't somehow specific to the MSTEM program, what can generalize out. And then, of course, we have to deal with infrastructure limitations and figure out how we can scale this up within the system that we have. In theory, it's all doable, right? The data is the data, it's there, and there should be ways to sort and clean and analyze the data that can be fairly automated and hopefully step away from this very effortful process that we're doing right now on a student by student, class by class basis. But I think the promise is there. Then we're also very concerned with this issue of motivating students, and this is where I think we're really overlapping and tightly linked with Tim's project, where he's going to already have some data for us about what happens when you send students these messages and how are they responding to them. What we want to be able to do, of course, for both what we're telling instructors and what we're telling students, is have a system that truly encourages change where it's needed and not discourages it. The last thing we want to do is give instructors a spreadsheet that they look at and say, well, these kids are lost causes, they're going to flunk my course, so I don't need to worry about them. And similarly, we don't want a student to get a message from the system and just say, you know, that's it, it's over for me, it doesn't matter what I do in this course, I can never catch up. So we want to be sure that the information is timely so that there is always a chance to intervene, and also that it's presented in a way that's actionable by the student, and then finally that the resources are available for the student to do something about it. So if there aren't wonderful places where they can go and get tutoring, get support, meet with mentors, go to professors, that those things have to be in place, because what we're not doing is creating a system that eliminates the need for support services. We're not a cognitive tutoring system that we can just keep running the students through a bunch of problems until they get the right answers, right? We need the people involved in the system. So, but there are interesting work now being done, some of it in my school and School of Information, about things like gamification with badges and leaderboards and so forth. Personally, I'm a little bit hesitant about those. I think we need to have a clear idea about who they motivate and how, and what are the appropriate uses for them. Right now, we're telling the student a very simple message. Relative to everybody else in this class, this is how you're doing. And I think that that's a fairly straight thing to know. It's been very effective in distance ed. We have some colleagues in the Sakai community who created a system for distance ed students who never see each other in the classroom and don't have a sense of how they're doing relative to everybody else. They find this information very useful and very helpful. And you can imagine that particularly for students in MSTEM who maybe are less confident or have a less experience in the academic context than some of their peers, it might be really important for them to know, how am I doing? How should I be doing at this point in time? Yes?
Are you looking at time in self-assessment? Like how students doing compared to the others?
Well, how they think they're doing?
Exactly.
Well, we know some of the feedback from the mentors that students are not necessarily good, they're not necessarily good at doing this. So it's students who think they're doing poorly may often hide out and be less likely to seek intervention. Students who are overconfident about how they're doing and think they're doing better than they are, they're also not going to go seek resources. And then it comes as a big surprise to them at the end of the term that they're getting a C and not the B+ they thought they had or whatever. So I think it's important to understand what students think they're doing, but we can give them clear feedback about how they really are doing. I remember in John Campbell's signals thing, I don't know what he said to you here, but I was speaking with him in another context, and he said that for their students, they all knew their color, but when you asked them, how are you doing in this course, they couldn't really be too specific about why their color was the color it was. So we want to provide information to both the students, like the mentors have asked for more detail. What does that color mean? We'd like to have both the instructors and the students be clear about, so why are you red? And what does that mean, and what can you do about it? And then, of course, we have to work with faculty because, as we said, our hands are tied if the grade data doesn't live in a system where we can go get it. So we need to either be able to more easily tap into the alternative grade books that faculty are using, or recruit more of them to use the gradebook tools that are available inside the system. We can't assess student performance when we don't have data about how their performance is going. So that's another sort of people and technology integration that we'll have to work on. So just in summary, what we really want to do here with our system is to close this gap between when a problem is identified and when we can do something about it, whether it's us or the mentors or the faculty or the students themselves. And we want to, like what we're all here in this room for, is we want to increase our institutional capacity for doing these kind of analytics, for making use of data that we already have in hand and apply that to the realm of teaching and learning so that we can do something there. And as you've seen in our project, analytics is just a part of that. Because as I said, we're not taking the mentors out of the equation. We're not taking the support services out of the equation, but we can use the analytics portion to bolster the effectiveness of those particular parts of the program. And the other thing that we want to make sure of, and some of your questions today reflected that, is you're giving people data that's subject to interpretation, right? And so you want to make sure that that interpretation is what you intend it to be, that you're leading them to where you want them to go and presenting it in a way that they're not freaking out or overreacting or dismissing it because they're interpreting what it's telling them in a way that you aren't expecting them to. So let's just leave it at that. And any further questions that you have for our team here? I know we're a little after 1. Yeah, Kara.
As part of that subject to interpretation, do you have a sense of how much training it took with the mentors to get them to understand these numbers and data?
Guys, what do you think? Who sat with the mentors? Or Cinda Sue, do you remember having the mentors talk about it?
In terms of training and interventions, the mentors had a long career already doing this.
Yes.
Coaching with the students, but I didn't get the sense that it was a lot of hours in terms of interpreting.
Yeah, it wasn't a lot to figure out what we were displaying and what that information might mean to them. As we're talking about going further with this type of thing, displaying distributions, of course, to students. Like that's a real sort of test case where that's the boundary condition. When we have a large audience who's getting a lot of information, how the variation in how they interpret that's going to be much wider, and how can we design those displays to help get the most out of that?
I mean, in this case, one of the other advantages of the MSTEM mentors is they are seasoned and well-informed, and they know these classes, so they can look at a class and know what it is and who's teaching it and say, oh yeah, the students always have trouble in the early part of this class, but right about this point is when we see them. For those who are going to take off, we can look for it right here, and so they could contextualize it.
I can also add, you mentioned that James Holloway, our associate dean, was very skeptical about this when we first started, and after a 1-hour presentation that you did, he was sold. And
Yeah.
he said, oh, I
Yay.
can see the Engineering Advising Center should have access to something like this. So he was very enthusiastic.
Yeah.
One thing I would say about people's experience with courses and stuff like that from advisors, you know, I'm an advisor, I have all kinds of opinions about what I think happens in classes, and they're very rarely based on very much data.
Uh-huh.
And the students you talk to about courses and things are usually very funny subset of all the students in the class.
Oh, yeah.
So providing real information to advisors is also extremely useful.
Yep. I think there was another hand up back there. Yeah.
In the mentor summary, you gave more of a context or description of the assignments. Does the mentor have access to the full syllabus or an overall sense of these assignments were part of the whole?
In some cases, yes, they have access to the syllabus, especially if it's one that a mentor has had a partnership, meaning course, and they know the instructor, they'll have that information, but also the student can bring that information into these individual meetings as well. So I can't give you a great straight answer saying yes, they have access to the syllabus, but in some cases they do know. And then because the instructor's putting that assignment name, there's enough information in there that the mentors can go, okay, that's what this assignment is. This is a test, or this is a paper, or something along those lines.
I ask because the example of the individual classes, someone was taking Italian, and then the other classes were the core chem, math, and physics, where if you have 2 midterms and a final, and your homework counts for 10% or something, that those big benchmarks, it could be you can lose 50% of where you are if you bomb one exam, as opposed to Italian, where your points are, they're,
Yeah, incremental. Yeah. Mm-hmm. That's right.
And we're just at the mercy then of the gradebook in that case. And especially as we go across numbers of courses. Like I said, we have 648 unique combinations, so we are at the expense of people who have a midterm and a final to everyone who has weekly assignments. And so that's why the classification scheme is kind of structured the way it is, to hopefully just give you a raw number and then provide those assignments and let the mentor sort of interpret what that number might mean.
Mm-hmm. In the back there, yes.
I'm not sure if this question was just asked or if the answer just made me think about it a little bit. But do you show the students some of the data that the mentors use to pull these students off? And
No.
you just don't think that's useful?
Right now, the way our intervention is structured, we're just providing this to the mentors and not sort of telling them how to use it with the students. And based on the interviews, they are not turning this information out to the students.
Yeah,
and
so they're not saying, this is how we identify you.
No.
But you did point out that you're not sure, how to say something to a student without demotivating. And
That's why right now we're leaving it up to the mentors to have the discussions with the students.
And keep in mind that prior to this, these students are meeting with the mentors on a monthly basis, and they're
In the first year.
In the first year, and they're expected to bring in a report of their grades that they self-produce. So this is the system.
So originally, right, so originally we just envisioned the system for the first year students who had to meet with mentors anyway. Sometimes, as we said early, they didn't bring their slips or they forgot to fill them out, or maybe they skipped a month or two, and the mentors felt it was a real problem that sometimes they wouldn't find out until it's too late that the student is doing poorly. But once we started providing this information to the mentors, they said, oh my gosh, this is great. Can we know that about our second year, third year, and fourth years who aren't required to come to these meetings? Because we still care about them after their first year. We still want them to succeed. And ultimately, their GPA is cumulative over 4 years. So if we want them to be competitive on the job market, we can't just bolster their GPA in the first year and not worry about what happens after that. Anything else? Anyone else?
Well, maybe make one quick comment. Because you have information that isn't just the grade book, but is also some measure of their activity in class.
Right.
You have the ability to tell them not only how they're doing, but how what they're doing compares to their peers.
Right.
And that's something that they usually don't have much normative information.
That's right.
They might not know that their peers are doing these things to succeed.
Yep.
So.
Yeah,
it's possible to.
There's a little educational implication there too. I think of then the distance learning example. They say things like, 80% of the class has read this supplemental article, but you haven't. So that leads you to say, well, wait a minute. If everybody else is reading it and I'm not, maybe I should also be reading it, kind of thing.
Never downloaded the practice test.
Yeah, 80% of the class downloads the practice test. So.
9%.
Yeah.
Whatever.
So.
Yeah.
Okay. Well, if you have any further questions, we're around. Thank you for your attention, and we hope to continue to keep working with you. Thanks.
Thank you.